Hello and welcome to a ANSYS video tutorial for beams on elastic foundations. In this example problem and tutorial, we're going to be working with a beam, an I-beam that has been hung from straight vertical steel bars. And the spacing for these steel bars and length of these steel bars has been given in the problem statement, problem 1012 in your textbook. The dimensions of the I-beam are close to a W150 by 18. The dimensions are shown here. The stiffness of these vertical members can be computed by AE over L. Given that, we get 2.03 e to the 7 newtons per meter. Computing the little k that goes into the beta term, we compute big K over L, and then we substitute that k into the beta term. Computing beta, we get 1.467. Now what we need to check is to make sure that the spacing of these vertical members is sufficient. So I compute the little l less than or equal to pi over 4 beta. When I compute that value, I get 535 millimeters. The problem statement says that little l is 500. So based on little l and the spacing of our vertical members, we are okay. Now, in order to do this in a finite element model, we need to compute the minimum length of the beam that is required in order to use the basic equations that we could then use to compute hand calculations for. This is not a minimum based on a finite element analysis. The finite element analysis would obviously compute the right answer if modeled correctly, but to compare with book answers, we want to make sure that our beam is at least 3.21 meters long. So based on this information here, we're going to go ahead and start to develop our finite element model in ANSYS. So to draw this system in SpaceClaim, the first thing I want to do is come to File, SpaceClaim Options, and check my units to make sure that I'm in millimeters. So indeed I'm in millimeters, so I can go ahead and cancel this. Now I'm going to draw this beam along the z-axis here, so the vertical members will be going in the y direction. So I'm going to right click, select new sketch plane, and I'm going to draw them in this XZ plane. So I'll click on that. Now I can look at this in a plan view. And I'm going to come and draw the circle here. So I'll come to sketch mode, circle, I'll click the center and extend this out. And these are 18 millimeters. So I'll type in 18 and enter. Now I can rotate this and I'll pull this in the positive Y direction. So I'll go to design, pull, click this face, and they're 2.5 meters long, so I'll enter in 2500 millimeters, and there I've created my first rod. I can look at this now in the X direction and rotate it so that I'm looking in Z, and if I zoom out a little bit, I can now see my rod and I can see the directions that I want to have it in. And so what I'm going to do to create the other rods is I'm going to control middle mouse button and move this down to here. And now all I'm going to do is copy and paste. To do that, what you do is you use the move tool under design. I'll click move, and then I'll click on this solid here, and you can see this axis show up. If I hold down the control key and click on the z-axis line, I can move this and actually copy it. And I'm going to copy this. So I release the control key, type in 500 and enter. And there's the first copy. Now I can control, move it again and move this one 500 millimeters and just keep repeating this until I have moved all the units that I want to move. I could also come back and click more of these and do more of them at a time. So for example, I could click off everything, click, control click, and now I've got these three selected. Or I could come over here and I could click on the top, shift click the bottom and have all of them selected. And then I can come down here, hold down the middle mouse, or excuse me, hold down the control button, click on the x-axis, and I can move these out to here. And I know that that's got to be around 500 millimeters, so it looks like I need to move that a distance of 2,000. So I'll type in 2,000. And now I've made quite a few more bars. I've got 1, 2, 3, 4, 5, 6, 7, 8. My calculations earlier showed that I needed to have 9, so I'll click on this last one, and still under move, I'll hold down my control and move this 500, and I have my vertical bars developed. Now here's kind of an important thing. You'll notice that this last one was created as a surface. If you're not careful and if you don't copy and move the solid, it will be created as a surface, and that won't help you out. You need to have these solids. So I'm going to come back here and undo that, and now I'll just click on the solid here, and I know that I have the solid. I can hit my control, grab the axis, and move this 500, enter. And now I have all of those. And I'm ready to start to create the beam. To create the beam, I'm going to sketch in a different plane. So I'll change my sketch mode. So I'll right click, and you can see that this says detach all or use last sketch plane. So if I click on that, that shows me the sketch plane. I can right click then and click select new sketch plane, and I want to click that vertical sketch plane right there, and so I'll click that, and now I can hit plan view, look at this thing face on, and zoom in so that I can see where I'm developing my I-beam cross section. And I'll make this a little bit bigger so it's easy to see, and then center it. So to create my I-beam, I'll come back up here to sketch mode. I'll click on the line tool, and now I'll come and I want the center of the I-beam to start right there. So I'll click there, I'll drag this point out, and based on my I-beam dimensions, this is going to be 51 millimeters. So I type in 51, enter. Now I can click and move this down, and I move it down 7.1 millimeters. And there's that line. Click it, move in, and I'm going to move in 48.1, enter, millimeters. And I just keep outlining my geometry like this. Now I can move this one down 138.8, so 138.8 millimeters, and hit enter, and that gives me the line there. You can see that I wasn't vertical on that one, so I want to come back up here and hit the undo command on that and undo that last line. Make sure I'm still under line. I'll come back and click it, move vertical, and I'm going to enter in the 138.8 millimeters, enter, and that gives me my next line. I'm going to go ahead and pause the video while I do this, but you just keep continuing to outline the structure. So now that I have my I-beam completed, at least the cross section, I'm going to come up here to design and click on the pull tool, and I'm going to pull this cross section. And I know that I want to put a load in the middle of this beam. That's what the problem statement said. And so I'm going to pull this half of the distance, and I can rotate it a little bit more sometimes and zoom out and see a few more of the beams just to make sure that this is going to go the way I want it to. So I can come up here to design, click the pull, come down and click this face. Sometimes you might need to zoom in a little bit in order to get the face if the lines are close to each other and hard to get. So make sure you grab those. And if I extend this 2,000 millimeters, that'll put me in the center of where I was looking to be. So now I have that part of the beam created. I can control middle mouse click and move it, and I can zoom out a little bit more. And now what I can do is come and use the move tool. I can grab this solid, and you need to make sure that you grab the right solid. And so you can scroll through these and see which ones light up. And one thing you can see that now is this one solid includes the beam and all the vertical members. And I probably wanted to keep those separate. So I'm going to go ahead and hit the undo command and undo that pull. And now on my pull tool, I'm going to come down and hit the no merge command. Now those won't merge as it is pulled, and I'll redo this. So I'll pull it 2000 millimeters again. And now you can see that I have my individual solids over here with all my bars, and it didn't combine them. So I can click on my last solid, which would be this beam, and I can copy it. And so I'll control move this to the center, and now I can click on move, and I can control click the axis and move this. And if I move this down here 2000 millimeters, that will put me on the other half of the beam. So I'll enter 2000, enter, and now I have my full beam, and I have a face in the middle. Now, in terms of the Therian stuff, it likes to have these ends extend half the distance out past the end of the beam. So I'm actually going to pull this again, but pull it in the other direction. So I'll come here to the pull tool. I'll make sure I'm on no merge, and I'll pick this face. Probably have to zoom in a little bit again to make sure I get the right face. I can click that face. I can come up here and I'll pull this, and half the distance would be 250 millimeters. So I'll type in 250, enter. And now my beam extends out past the vertical holding rod like it's supposed to. I can come now to this end, rotate it around, and I'll do the same thing on this end, where I'll zoom in and select that face and extend it out 250 millimeters. So I can make sure I see the right solid there. I can see nothing's merged, so I'm okay. I'm going to come here and click this face, make sure the no merge is lit up or highlighted, grab this and pull this 250 millimeters and enter. Now I can come back and look at my beam along the x-axis and zoom out a little bit so that I can see the whole beam and the whole system. If I off click there, I can see my vertical rods. They look great. I got a vertical rod and a plane in the middle of that. I extend out past my ends like I'm supposed to, and I'm in a position now to go ahead and read this into ANSYS Mechanical. So after opening ANSYS Mechanical, I see that my beam came in as two parts, which is expected. It's extended past the last vertical support, and I have my vertical supports. I also have a vertical support here in the middle where I'm going to put the forces. So that's all expected from the geometry that I imported. I can open up my geometry here, and I can click on these individual bodies and see what system is what, and the bottom two are my beams. I can see that they're all made out of structural steel, and I could edit these and change these as needed. So I'll go ahead and close this. Now I'll come to connections, and in this case, the connection between the vertical rod and the beam is critical. In terms of accurately modeling this, it would be important to know how these rods are connected to the beam. I would not imagine they're welded, but that is how they will be treated in this model. So if I come to the contact region, the first one, I can click on it, and you can see that this top surface is in contact with the bottom of this rod. So you can come over here and rotate this rod around and see that, and you can see that beam is connected there. The next contact region is just the next vertical member, and you can click through and see all the contacts. When you come down to contact region 11, you can see that this is the contact between the two beams, and it is also a bonded contact. So this will essentially act as one single beam. Again, you may want to use a different type of coupling here. If you knew more specifics about how these rods were connected to the beam, you could model that, because right now there is going to be a bending moment allowed here in this rod, and that may or may not be actually what you have in your scenario. So I'm going to go ahead and close the connections, let them be what they are. I'm going to open up the mesh coming down here. I'm going to increase the resolution of this mesh up to 6 from the default of 2. And I'm just going to go ahead and say generate the mesh and see what it comes up with. It is meshing pretty quickly. The meshing's done. I can come here and I can click on mesh and I can see the mesh. If I zoom in, I can see that my beam elements, or the solid elements in my beams, look good. I can zoom way in and I can see that the elements in these vertical rods look good. And as far as a first try at a good mesh, that seems like a really good mesh for this point. So I'm just going to go ahead and accept that mesh. Now I'm going to come down here to static structural, click on the environment. I'm going to start to apply the boundary conditions and the loads. So on the boundary conditions, what we have is a displacement boundary condition on the tops of all of these vertical members. And so I'm going to get these to where I can see the faces on them pretty well, and rotate this around and make sure that the faces are clear and that I can select them easily. So if I come down here to the displacement, click on it, I can now zoom in probably a little bit more. I'm gonna have to. I'm gonna make sure I'm on the face select tool, and you can see that highlights in red when I touch on it. So there's the first one. Control click the second one. Now I'll move my body and continue to control click all of these upper faces. I could have done a box select or a lasso select and got them as well, but with this short number, it's just about as easy to just grab them individually like I'm doing here, and then move it down and grab my last one. And to make sure you got them all, when you come over here and click apply, you should see that there are 9 faces. I only have 8, so I need to go ahead and see which one I missed, and it looks like it was this very first one. So I'll go ahead and rotate those, and I will pick these faces again. I'm on face select. I can see that one, and the thing you got to be careful with is oftentimes, like I just did, you'll select the face of the circular rod, and that's not the face that you want to get. So you've got to be careful with that. So I'm going to start over and grab those top faces. Having done that, you can now see that I have 9 faces here. These are going to be fixed in the X, Y, and Z direction. So I'll hit 0, click enter, 0, and enter. And now all of those top beams or bars, the support rods, are going to have 0 displacement in X, Y, and Z directions up at the top. So now I'm ready to apply my loads, and this is where you need to be a little bit careful about how you apply this load, and it would be better to understand the real physical model that you're developing here, because it's probably a distributed load over a given area. We're going to treat it a lot more as a point load. So one way I can do that is to control click. I can come up here to force and click on force. Now I can open up my geometry, and I can click on one side of the beam and hide that body. I can rotate this now and zoom in and grab that face. This is why I made 2 beams to begin with. I can come and select this face and come over here to my force and click the selection and apply it to that force. I'm going to click on vector and change this to components, and I'm going to put in a minus 60,000 newtons for the force, and you can see that it shows up there. Another way to do this would have been to apply the force to one of these lines, possibly the top line. I could also create a named selection and apply the load to a specific node. So lots of options here. You want to make sure that you try to do that which would be most representative of your actual model. So I'll show all bodies now, and I now have all the bodies shown in my model. I'll hit this ISO and zoom out a little bit. Model's looking pretty good. I'm going to come down here to the solution, and I'm going to want to look at the total deformation. I'm going to want to look at the directional deformation in the Y direction, so along the Y axis. I'm going to want to look at the equivalent or the von Mises stress. I'm also going to look at the normal stress, and the rest of these I could look at. I could look at a shear stress or whatever, but those are the main ones I kind of need. You could also come and enter in some of these other values if that's what you're looking for, but let's just see what this gives us for a start and see how we go. So I'm going to come look at my model. Everything looks good here. I can close the geometry, and I'm going to go ahead and hit the solve. This is actually a pretty fast solution down here. You can see we're at 10% already. I'll just pause while it completely finishes. So here's the results from the model that I looked at. If I go ahead and click on the total deformation, I can orient this along the x-axis so I can see. And if I zoom in on this a little bit, I can see that I've got a lot of significant stress right on these two flanges where the beams meet together on the outer edges of those flanges. The rest of the stress or the deflection is minimal out through here, kind of on the range. If I click this probe button, I can come down here and probe this, and I'm looking at 1.2, 1.25 type millimeters. If I get in the red, I jump up to 1.42 and so forth. And down here you can see that I'm up at 1.47. If I look at the equivalent stress, I can see that I'm highly stressed right here in the middle where my middle rod is holding. And if I zoom out and rotate this around, you can zoom in again, and you can see that there's a lot of significant deformation going on there. And that might be the way to apply the load. If I click on the normal stress, I can click on normal stress, and it will now show up. And I can see that a lot of my beam is under a minimum load, but then right through here, based on that normal stress, in this area, it's extremely high. So I can come back and do my ISO view. The one thing that looks good in all the rods is that my tension is uniform throughout there, and I don't have changing colors when I'm looking at my normal stress. If I look at the total deformation, there certainly should be changes in that deformation as we grow closer to the bottom. Along with that, we can see that the members that are further from the center or where the load was applied have less deflection, as would be expected. Again, I'll look at this in the x-axis and zoom out. This may not be the way you want to apply the load, so I'm going to pause this and show you another way to apply the load. So the other way that I'm going to apply the load is to apply the load to a particular node. And I'm going to apply the load to the node that is right underneath this vertical member here in the middle. So I'm going to get that node right there and apply a point force at that node. So coming back here to all my solution, I can click on the force. That's what I'm going to look to do. I can look at the mesh and move this down and kind of make sure that I zoom in on the right node, and that I have the opportunity to click just that node, because there's a lot of hidden ones in between, and sometimes you can click the wrong one if you're not careful. Now I'll come up to geometry and I'll click on that vertical member. I'll hunt through these until it highlights, and I'll know that's the right one. It just turned green, so I'll right click and click hide body. Now I can come back and click on mesh, and that right there will be the node that I want to select. So I come up here to model, right click, insert, named selection. Down here at enter to named selection, I'm going to go ahead and select the geometry component, and I'm actually going to pick a node. So I'll come back up here to mesh, and I'll come up to the node select, and I'm going to come and pick that node right there. And then I'll come back down to named selection and selection there, and I'll click apply. And you can see that it didn't show up. So what I've got to do is pick that node again, pick the node, come over to apply, and then I have the one node. So now I've got the one node, it's under geometry selection, and I can go ahead and keep that. And now when I come down to my force, I'm going to go ahead and enter in direct FEA force. So under static structural, I'll hit direct FEA, and I'm going to put in a nodal force. You can see that that highlights over here. I'm going to come, and it wants a named selection. So if I click the drop down here, I only have one of these, and I left the name of it selection. So that selected that node, and you can see that highlighted there. I'm going to come here and put in a minus 60,000, the same load that we had before, and enter. Now on this force up here, I want to make sure that it's not applied as well, so I'll right click on it and click suppress. And now I can come back up here and right click and show all bodies. Just to make sure my force is there, I can click on that nodal force, and that tag lights up, and I can see that it's 0 in the X direction, minus 60,000 in Y, and 0 in Z. So now as I scroll out and look at an ISO view, I've changed the way the force is being applied in this model, and I'm going to go ahead and hit the solve button, and we'll look at how the results are different. So I got a good solve. All my check marks are green. I can look at the total deformation, and you can see how different it is now. If you remember, we had kind of a hot spot on the flanges, because when we select that face, load was being applied to the flange part of the I-beam, and now that we're applying it just at a single point, you can see that we have a uniform deflection kind of through the cross section. When we look at the stress, though, we come here and look at the equivalent stress, we can certainly see that there's a hot spot right there where the load was applied as a point load. That is to be expected. If we come down to the bottom, we don't see that as much, and you certainly don't see the flanges as red as they were out towards the end. We can look at the normal stress, and again, our stresses are a lot more uniform throughout. If I click on the Z and then come back to the X-axis and look at this, I'll have to rotate it a little bit. Now look at the X-axis, and you can see that our beam is in a different situation. The loads and stuff are significantly different, even though we applied the same load just in a different way. Another thing to kind of point out is you can see how these members here actually bend, and that's because my beam's being bent, and these are, as we have them now, moment carrying connections, and so as it bends, it's going to bend that bar out. You can see out here onto the end, it seems like our beam's long enough, and that this vertical member seems like it's affected very little, and our beam out here seems to be affected very little. We can also look at the total deformation or the directional deformation and see that as well, that up here in the red our deflections are much less than down here. Now, one thing again you can do is you can come to the probe, click on probe, and look through your geometry. And if you want to look through the solution to this problem, you're going to see that your maximum deflections are certainly in the neighborhood of what was computed. And with the hand calculations there, we're looking at a minus 1.2. If we come back to a normal stress and come to our probe, we're looking at a compressive stress and a tensile stress with a maximum around 292. But if we look at the main colors in the beam, or kind of zoom in here, we can see that we're in the area of this 97 range. I can take again a probe and click on probe and come down here and get the values for these normal stresses and compare them to what we have. Note the units are in megapascals, so this would be 4 e to the minus 2 megapascals. And you're going to see that those compare fairly well to the solutions in the textbook as well, or your hand calculations. So I hope this video has been helpful. Thanks for watching.